Hey, hi. Uh, the main idea about today is to discuss why I started this particular project called niniBUS. Before going into the details, what is niniBUS and why I have choose to create it, let's discuss the motivation around it. Okay. So myself. Uh, have almost 13 to 14 years of experience, more than a decade. I didn't do anything great yet. And that's the motivation, right? Okay, the idea is that I am an embedded software engineer. So most of the thing I worked is in embedded system and something beyond the embedded system also. So my current role, I worked in creating the simulation model of the hardware associates. Interesting one. Slowly, uh, I developed an interest towards the runtime things. The runtime things I mean to say is that how do things run? We know that operating system is something which runs all the devices, right? All the embedded devices, IoT devices, even of your cars, your vacuum cleaner, right? And I was interested. I am interested in all those things, right? To know how things run beneath it. It's not I love the operating system, but I love the idea how things run, right? As an engineer, every times we love those things, right? How do things run? How do a server manage a lot of things too, right? I am interested also run learning apart from the operating system. I have interest in learning the message queue, the database, and few other things. Yeah, some people tell, and it's true that it's not directly related to the embedded system as such. I agree to this point up to certain extent, but slowly the what I felt, uh, the lines became blurred. There is nothing called an embedded system and a backend system. Everything the lines are getting blurred slowly, right? And I think that's one of the reason we are going so fast in the technology, right? And the AI and all these tools are helping us to learn things quickly. We should not be domain specific. Saying that, what I learned or what I observed about my behavior is that I see every shiny object and I just move around to all the shiny objects, right? So today I read something about database. Okay, I thought, okay, the database is beautiful. Let's build something. Then tomorrow I read something else, a message queue. Let's build something. Next I read something called discrete event simulator, which I work on. Okay, okay, this looks beautiful. Okay, let's create another uh, distinct event simulator. So I hopped around, right, from one thing to other, and at the end I realized I completed nothing. There's nothing in my bucket to show that I something I created from the scratch. I have a problem statement. I have my own trade-offs. I have my own design. I have my own optimization techniques because I just hopped around, right? So the idea of the niniBUS is to make myself an executor instead of hopping around all the shiny things. What I see. That's what basic. I don't know. Uh, I can able to complete the niniBUS but hope so I can do it. Okay. Uh, Before going more details into niniBUS, the architecture, what I am doing, what I am designing, let's keep this things little bit more simple. What actually niniBUS looks like. So the name is a little bit crazy, right? niniBUS. Nini is something which closely related to something called small little things, right? Nini. So bus is a bus, right? So do not think it's an embedded driver kind of thing, a bus or something. No, 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 no. It's not. I'm not going into those details. I'm keeping the niniBUS as an use case uh, in uh, the use case is like you have an IoT devices, right? You have a vacuum cleaner, you have an automotive system like a car or a vehicle. So you have seen like there are multiple inputs are there, right? Multiple sensors, actuator, multiple processes running, and some everyone is producing something and other one is consuming that one, right? That's how things work, right? You produce something and the consumer will consume that one and he will compute something and he will produce something else. Okay, that's how things works, right? The main thing is producer produce something, consumer consume it, right? And it's an easy one, right? Like you produce something and someone is going to consume it. But when you have multiple producer, right, and multiple consumers, you need something in between which is going to hold your data, hold your produced item, and it can safely transfer those produced item to the consumer, right? Or maybe the consumer can hold it as per its wish. Okay. So someone is there need to hold the data in his place, right? Some data structure you required, right? So this is the basic idea of niniBUS. So niniBUS is at this moment I am creating a data structure, not a process, not a thread, nothing else, just a simple data structure. It will data structure. The bus will be niniBUS will data structure. Someone going to produce something, put in the data structure, and the consumer will pull that one. At this moment, maybe we can later on we can try to poke the consumer that hey, data is scam, you can take it. But at this moment, let it keep it simple. Let's producer produce, put in the data structure, and the consumer come and pull it. Okay, the idea here is also that producer can produce multiple data, right? A sensor may in every 10 millisecond try to produce a data and it will put into the bus, right? And the consumer at this moment how I designed pull the data, right, one by one. Okay, do not go at this moment. I am not going to discuss about the multiple producer, multiple consumer. Let's keep it simple. Let's create things as boring but concrete, right? I am not claiming here that my things are going to optimize to one, the best one in the industry, nothing like that. It's just a learning project. Okay. Want to be an executor instead of a running behind every shiny object, right? So this is how uh, I am working on, right? So as we learn, right? So the bus, what I'm trying to tell is that it's a bus. You can think it's a bus running on multiple lanes, okay? And each lane has some lane ID, right? You put the data on that lane ID. Your producer put the data on that lane ID, and your consumer will pull that data on that lane, right? So simple, right? You run the bus on a lane number 30, maybe message 1, message 2, message 3, message 4, someone put on the lane number 30, and you have a consumer taking the data one by one out of it. Okay, I am at this moment lazily telling one consumer because I don't want to go into details of multiple producer and multiple consumer, slow producer, fast consumer, or the vice versa. All those things we'll be discussing later slowly as we derive the architecture, right? At this moment, keep it simple. Just data structure, put the data, get the data, right? It's data structure. It's nothing a process, not a thread, nothing like that. It's not an computation unit as it is, which can run independently at this moment. It's a data structure like a queue, maybe like a map or something like something data structure I'm creating, right? That's the idea. Okay, so as we talk, what I discussed here is that in producer put the data on a lane. So closely think a lane is a lane ID 100, and a producer put data 100, message 1. Again he publish one more message, publish 100, message 2, publish 100, message 3, and message n. So now you can think in a single lane I have multiple messages, right? That means I need something here which can hold my messages. And when I poll the subscriber, going to poll it, it will take the first data, right? Like message 1, message 2, message 3, message 4 from the producer. Consumer, message 1, message 2, message 3, message 4. Okay. Simple, right? It's a fast in, fast out. Queue, right? It's a queue. So if I create a class around it, how it will looks like? I will have a lane. In that lane, I have a queue. All right. In a lane, I have multiple queues. Oh, sorry, single queues. Single queue. One lane, one queue. Because one lane is 100, lane ID 100, so multiple messages, but single queue at this moment. Later can be changed, right? We will change maybe. So I can have now multiple lanes, right? 100, lane number 101, 102, 500, something like that, right? So I can have multiple lanes. So for each lane, I have to create one object of that class, right? So lane 100 is a object, lane 200 it can be another object, lane 300 another object, and every object have his own queue, right? Yeah, that's good. But the problem will happen, how do I store this lane number 100 have this object, lane number 200 have another object, right? Yeah, that's interesting. Looks like a map, right? Looks like a map, right? So if I do, once I publish 100 with message 1, I can create a map with the first thing of the message ID or lane ID as a key, and one object of the lane, right? Object of the lane class. So next time a consumer want to read 100, lane number 100, I can scan through the map, get the 100 as a key, and the value is the object, and the object of the class lane, right? And the lane stores the queue. I got the access to the queue now. So I am going to store a map. The map will have a lane ID and an object of the class lane, and the lane class have the queues. Simple, right? Okay, that's fundamental things. So let do some discussion around it and think how it's gonna. Let me get it to. Okay. So I explained the why part. So now the thing what I'm trying to explain here is I have a land class, right? I have a simple land class. So okay, let's have a class called okay, something over here. Okay, let me take something else to. Let's get some whiteboard kind of thing, which will be better to explain. Not why not notability. That's a good one. Okay, this fine, looks fine. So what I'm trying to tell here is I have a class. I have a class here. Okay, that's called len. Okay, for len. This is a class, len class. So, and as we discussed, I have a map, right? I have a map. Okay, so this map have keys and values, right? Key and values, right? That's how a map looks like. Okay, okay. So let the publisher publish a message, some key 100 and some message 1. Okay. So now what I'll do for the first time, I don't have anything in this map, right? Empty. Map is empty. So this is my len ID. What I'll do, I'll try to create an object of len type. So let's create an object len. Okay, some object which is like my len class, right? Interesting. I created this object. Now, okay, as we discussed, right? Every class have a queue. Every class have a queue data structure, right? Let's queue name is content. That is the message I'm containing. So I will put this object dot content some post message which is like my message. So now this is object created. Now this object is created, right? So now what I will do is simply I have now an object created for the len ID 100. Okay. So I have object created for the len ID 100. I have object created. This is object I've created, and it have a queue inside. So what I'll do, this object, if I store it here with an ID 100, wow, nice. So now something is stored. Now the next time, again the publisher publish a message 101 and some message 2, right? Now again what I will do is I am gonna create one more object of the len class with a queue content. This is for 200 or whatever the publish I published, right? This is for 101. Okay. So now I will create another object and I'll push this message. I'll put it 101 here and I will put this new object here. Okay. So now next time a publish came, another publish came with the same message ID let 100 and something called again, like again I'm pushing a message. Okay. So now think of it. As soon as I find 100, I can scan that I already have an object for 100, right? I already have an object for 100, right? I have an object for 100. So I can get that object again from that queue, from that map. I will scan that map. Okay, I have 100. That means I have the object created. I get that object and push that message to this queue. So first one in this queue one message, now I have again. All right. So this is how I am maintaining. Okay. So let's create a better picture around it. Okay. So what I am trying to here is I have a map. This map have keys and values. Values are object of a class. So like 100, 101, something like that. And I have a class of len, right? Inside that I have a queue. Okay, I have a queue. When I create the 100 lane ID for the first time, I create an object for this lane ID 100. Okay, and that we can store a pointer of the object. At this moment, keep it simple. Keep the whole data structure of the object here. Okay, so now I'm just pointing it, but it's not a pointer. Okay, so it have object now. Now I have 101. I have created another object. It will pointing to this one. Okay, so now when we have a new old like 101, someone published 101 again, what I'm trying to do is I found, okay, 101 is it in the map. I don't have to create it. I have get that object. I push that message. I have a queue here, right? So first time I push it on the here. This is my front side, right? This is my back. I put it in the rear side. Let now in subscriber or a consumer came, right? So let's consumer. I'm telling you, it's at this moment I've implemented it as an I've created it as an polling, right? Nothing such an callback. Nothing. I'm not poking to the consumer. I'm just creating the consumer will poll the data when it required, right? So receiver send 100. Okay, I will scan through the map. Okay, I find 100. That means I have the object now. I can get the object. From the object, I can go to the queue. I can get the first message and send it back. I am forcing the user to pass an message object here because I want to return them the status. Okay, I want to return them the status that object is found or not. This queue is the data is there or not. So I want to send the status to the consumer, and that's why I'm forcing them to pass the and message. And I want to pass them a reference so that I am not going to create a copy of that message every time, right? That's how things looks like, right? Okay. Saying that, so we understood, right? We have a queue inside a class of len, and something else we can have some members, right? So let's jump into the code and see how the code looks like, right? So this is the simple code. I posted it in the GitHub. Maybe everyone can find it. So it's a len.h. Sorry, I have the len class. Oh, I use this Codex chart a lot nowadays. It's simple, right? It makes things simple to build it, to make it, to run it, okay, to push things into GitHub and all those things. I love that one. It's okay to use AI nowadays, right? So I told you, right, we have a queue. So I use the queue for a specific purpose to maybe later when I have multiple subscribers or something, I can keep the data, right? But that's why it's okay to use queue also at this moment instead of the queue also. That's fine. Okay, and if I have a queue here and I have a capacities is there just to tell it's a bounded, right? I want to have this LAN can maximum hold 100 slots in the queue, right? So you should not send more than 100, right? And I will have that publish result. I will show you. Okay, let's keep it in the mind that we have a capacity to make it bounded buffer. Okay, so now we have a content which is a queue and some functionality like queue size, capacity size, some credit. I will discuss this one. This is one naive approach. Okay, I will discuss in maybe the next video. Okay, going to I have a push and a pop. Okay, this is the my len class. So I'm just keeping push and pop. So push and pop is only for this queue, putting data into the content. Now the main thing is niniBUS.cpp or niniBUS.h. So every time I follow, instead of going into the cpp file, I love to go through the include files, right? It tells me more about the data structure. That's how things looks beautiful, right? You can understand data structure. Okay, as we discussed, right, we have a len map, right? So we have a LAN map as we discussed, right? This is the map what we are talking about. This is this map, right? Okay. So in this map we have two things. One is the LAN ID. I should make it LAN ID, okay, LAN D or something, and the LAN object. This is the and the LAN, right? So this is the key. This is the value, right? And for the publisher and the subscriber, producer and the consumer, the entry point for them is this publish and receive, right? And the subscribe and all those things we'll discuss later. Publish and receive, nothing else. Okay, that's the fundamental things. So because of this, these two are only public. Okay, and we have a map. So now let's jump into the code. What I'm trying to do here is the producer will publish, right, LAN ID 100 and a string of message. If you see, I'm trying to tell them to pass the reference. Okay, no object copy. Every time you pass something, I don't want to copy it, I take your reference. That's how I designed at this moment. So what I'm trying to do, I'm checking, hey, 100 LAN ID 101. Are you present? Are you present in this map? Yeah, I'm present. Yes, I'm present. We know it's present, right? If it is present, do something. If you're not present, what I'm trying to do is, for the first time, 100 to 1, let LAN 100 came. It's not present, right? So what I created a new LAN, right? Okay, I created a new object of it, and I put it the LAN ID this into this map. This is the key value 101 or 100 to this object. Nice. So now if I can go here, I can say, okay, I created this 100 and this object now, and I put into this map 100 and object. That's what I did it here, right? Now I need to push that message what the publisher is publishing, message 100, okay, to this one. Okay, so I can do it here, new LAN dot push to this message, because this is the object, right? Or I can do same thing, right? I get this object, push this message. Interesting, this part is done. Now again one message came 100, right? 101, 100 again. The first thing I'm trying to check, hey, is this there is object created for the LAN ID 100? If it is yes, get that object, yes. See, here I have a reference. If I will not take the reference, the problem will happen. This object, what it will return, because it's not a pointer, it's a pure object, it will return me an object and which will be copied to this object, right? So this is going to be a new object, and when I'm trying to post it, it will not post it because this is a new object, and the object inside the map is a different one. It's not a pointer, right? I don't store the pointer of that object, I store the object itself in that map. And we can discuss and argue why to put the pointer and all those things, but I created it, put the object. So if I get the object and I put an equal sign, it can be a copy, right? It can be a copy. It's a copy object of this one, right? So if I push this object, this message into the queue, it's a different object. It's not same what is stored in the map. So that's why I have taken the reference. Alright. The beautiful thing of reference in C++. I love it. At the beginning I never understood why we need a reference. Right. But now I understood why I need a reference. So when you get the reference you know, right? That is the same alias to the same object, right? It doesn't create a new memory for you. Now I push that one. Simple, right? Now it's stored. Okay, and okay, I don't want to go into the push and how I'm returning, what I'm returning. That's a different topic. That's a naive approach in the niniBUS. We'll discuss it in the next session. Okay, this part is done. Now let's and subscriber come and try to poll that message on the LAN ID 100, and I'm trying to tell send me a message reference string. Because the reason I want the user to send me a message instead of returning the message, I really want to send the user status, not the message. The status can be yes, no, something else. Okay. If I want to return the message can go empty. Okay, message, there is something in the message, but I cannot genuinely send some status, right? The queue is full, the queue is empty, or something like I cannot send it back. So that's why I'm forcing to send me a message, and I want to send a reference. Okay, I want the user to send me the reference. I want to keep it as a reference. So the reason being, I don't want to copy. I'm just creating the message. I'm just making clearing the message. What I'm getting the message string. I'm just clearing it. Nothing is the message now. I don't know what the user sent to me, right? But I want to send him a correct one. If I have nothing in my message and I just return this message, right? User may have sent some garbage and expecting, and he may have an assumption that I sent him the garbage, right? Even though I don't have anything in my queue. I'm just clearing it. No, nothing in my message now. Whatever sent, I cleared it. Okay, then I will send it if I have something. I'm trying to find that map ID. Okay, you given me lane ID 100. I'm figuring out in my map. Do I have the 100? Do I have the 100? Yes, I have the 100. I have the object now. Okay. If you something send me 102, I don't have 102 in my map. Two scenario. I have not 102. That's a valid reason I can send receive status error. Think of something for the future scope, though it's not implemented yet. Think of the future scope. In devices where we have multiple threads, I don't have a control which thread going to run. Is it the producer or it's the consumer? Right? Maybe the consumer sending 102 expecting that I will send him a back some message, and the message must be sent by some producer before I run. Threads can run whoever runs faster. There may be different algorithms who runs first, right? Let's think a consumer thread runs first. Okay. So instead of returning 100 that receive error, that's how it will return, because I don't have that. But why should not I create an object for it? I know that sometime later maybe the producer came, a new producer can come with 102, and if I can create an object for it readily available, right? I can just create an object 102. I just create an object 102. I'll create an object 102. I'll create the object, but nothing inside the data. Just create it because someone asked me 102. I don't have. I just create and keep it. I'm expecting the producer will come, and that time the producer doesn't have to create the object. The object is created already, right? That's the idea around it. Okay. Okay, that's what I did it. If it is not there, I reached the end of my map. I don't have. What I did, I subscribe to this function subscribe. Doing nothing. It's doing exactly what I did here, right? Exactly the same thing. Okay, I think this is redundant. Okay, if the lane ID not present, if you see this one, I did it here again I am doing. Maybe this need to be optimized here. Yeah, it's need to be optimized. We can optimize here, but let it keep it simple. So again, if my lane ID is not present, I'm just creating the object and putting the object into this, right? That means I've created the object. I have nothing to post it actually. I'm just subscribing. Okay, that is the way your consumer also subscribing to a message, right? If it is not present yet, you are just subscribing, right? And once I subscribe, I'm just sending a message. Lazy lane is created. Lazy lanes means lane was not there. I lazily created a lane expecting there will be a publisher. Okay, and I sent this message back to the consumer, and I know the message is clear. So anything message will be clear. Nothing will be received by the consumer, right? Think that if I have that object, I have that mail ID already created. The second example, right? I have the land ID 100 is there. I get that object, I return it back. Nice, right? And that's how it works. Okay. So at this moment, I don't created any data structure lock free locking mechanism, multiple producer. I will be doing slowly. This is the core data structure we're creating, right? Just I'm thinking a single thread. Let's see some example. I can show you how it works for this. Single create a bus, publish, receive. Okay, single thread at this moment. I'm not creating multiple thread and multiple threads, multiple producer, multiple. We'll do it slowly and steadily. Okay, that's how the first part of it. Okay. See you then in the next. Before that, if you have a chance, go to the GitHub, look into it. We'll be slowly working around it, and we'll be together. We'll be creating more things, right? So I saw you trade ups, right? What I did, some trade, nothing much big trade ups. One trade up is I'm asking to the users to pass this message. I'm taking the reference of the message. I don't want to copy. Again here, I don't want to copy. I put a reference. That is the trade off I'm doing, right? I don't want to copy. And I don't have a pointer. I'm not keeping any pointer here. I'm just keeping this object. I can put a pointers. Now if I put a pointer, then this pointer tick, memory, it will create. I have to create this. If I have a pointer, I would have created with an if I have a pointer, I would have, instead of directly doing new line, I would have created new, and then I have to manage that new, how to delete it also, right? So all those things. Yeah, that's certainly required, I hope. The point is that if you're creating a pointer, but your object is already there, you don't saving memory actually. Instead of that, you are wasting extra 4 to 8 bytes of the pointer size in your map. Again, an object there, which is already that size of that LAN class, and you're pointing, and I think you are creating more computational overhead for you. You need to create the object, and you have to manage which objects are created and would need to be deleted. Otherwise, create object to created and heap gone out, everything gone, right? And no, make it simple at this moment. Maybe we can create an object pointer later. We'll think of it. We decided, okay, if we think of our design need to be changed, we'll definitely change. Okay, we need to be executor here, right? I want to be executor, and if someone else is watching this one and he is also hopping around this new object, we should create this together. Okay, saying that, next thing the next video I want to discuss about a new thing. That's, I think it's a nav thing which I'm trying to do is something called credit. Okay, and I want to, if you have some time, I want to go some design decision. Here I have written something called credit. And the idea of the credit here is instead of no, let it be there in the later discussion, but you should read the flow control of the TCP architecture, right? This credit is derived or taken the inspiration from that part of that from the TCP flow control. That will be a good point to be learned. Okay. With that, let's close this one for today. Maybe we will see once we will go for the next part of the implementation of the. Okay. See you. Bye.